the last lecture, we saw the use of pointers, arrays, and pointing a pointer to another pointer or a pointer to an array. So, we will summarize that by looking into this program. So, here is a program which would make use of many of this for a one-dimensional array. Okay. So, let us go through this program. So, we have declared an array here. Okay, and then we are calling a function called print. Okay, and the print passes this a pointer to this array, that is, we passing the name of the array, which is a pointer to the first element of the array, into this function, and then we are passing the dimension of the array, which is 5. Okay, and then we are passing the array itself. Okay, so we are doing 3. So this is basically to summarize what we did in the last lecture. So this, we are passing the address to the first element of the array, and we are passing the array itself to the function. Okay, now what does the function do? The function maps this address to another pointer j. So that is, we want to show how to point a pointer to an array. So here is this address is being passed on to another pointer, and this is being passed on to another integer n. And then this num, which is the array, is passed on to another array b. Okay. Again, this is, we said this declaration, the type declarations here can be either inside this function call itself, or it can be given just below that. Okay, so then what does this do? This prints out the address. So now we are going through a loop here. Okay, and then we are printing out the address of the array elements, okay, and 2 different ways. Okay, so we are going to print out the address of the array element here, which is by using this pointer j. Okay, and then we will print out the address of the array b, okay, here. So we will see that this will be always pointing to the base address, and this will be running through the thing. Okay, and to address to get the element of the array itself, we can either use asterisk j or asterisk b plus I. There are 2 different ways of getting that element. So that's what we would see here. So if you could just compile this and run it once again. So you can see that this is always pointing to one address, which is the base address of the array. Okay, and this is running through the array. Okay, and we get by referring to the array elements as either asterisk j or asterisk b plus I. Okay, we get the same answer. Okay, that's something which we saw yesterday. Okay. So another one which you should look at is again pointing a 2-dimensional array, which also we saw that yesterday. And now how do we point a 2-dimensional a pointer to a 2-dimensional array? So there are 2 different ways of doing that again. So we could either point a pointer to that array, okay, or we could point a pointer array to that array, to the 2-dimensional array. Okay, so that's again which is demonstrated in this program which we saw yesterday. We will go through this once again. Okay, that is, so we have declared a 2-dimensional array. Okay, so it has 3 columns and 5 rows. Okay, that's we have declared. Okay, again I said when you're declaring a 2-dimensional array, we will be always careful that we should always declare the number of columns. The number of rows are not important, but the number of columns are important. Okay, so now we have a pointer here. We have 3 different pointers, 2 pointers p and r, and we have pointed array q. Okay, so all type integer. Okay, and now we are going to point pointer p to the array. Okay, so that always when you do this, you have to typecast it, as I mentioned in the last lecture again. So we have to typecast it, so integer type and array. Okay, so we are pointing, now this is the pointer array which we are pointing to, the 2-dimensional array ARR. Right? So there are 3 different ways of doing it. Now we are using this pointer r again to point to this pointer array. Okay, so you can notice that again we have to typecast it. Okay, so this is a pointer, this is a pointer array. Okay, and here is a pointer, and this is again an array. Okay. So then we will print out all these quantities. That is, we would print out what is p, what is q, what is asterisk p, asterisk r, r plus 1, r plus 2, etc. So remember what we said was that when if you increment p here, okay, we increment p, it will just simply run through the array. While if you increment q, it will go from row to row. So if this q, which is pointing to the first row by this definition, first row, first element. Okay, now we have this pointer pointing to that array. Okay, and then by saying r plus 1, r plus 2, etc., we will get out the different elements of that row. So if you increment p here, it will go to the next element of the array, while if you increment q here, it will go to the next row of the array. So that's what you have to remember. Okay, and then every row we read off by pointing r to that array. And then we will run this. So what we do is we will first point everything to the base addresses, and then we will print out that, and then we will increment p and q, and again print out that. Okay, so that's what we see. So here we have the base addresses, p and q, both are pointing to the same address, and we are running through the array. Okay, so we have 11. So it's for p is pointing to 11, and this we running through that whole row, and we get 11, 12, and 13. Right, and then we increment p and we increment q. Okay, and when we increment p, which was a pointer, it goes to the next element of the array. While when we incremented q, it went to the next row of the array, and we have 21, 22, 23 as the elements of that row. Okay, so that's what we saw in the last lecture. So then now we have to now we were looking at is how to pass a two-dimensional array to a function. Okay, so now that's what we saw, how to read off two-dimensional arrays and how we can point pointers to that and pointer arrays to that, etc. Okay, so now we will look at how to pass a two-dimensional array to a function. Okay, so we said that there are 4 different ways of doing that. One is to pass an array to another array in the function. So that is here used as array a m dimension m and n, and that's passed on to another array b m and n. So we could do another way, that is that we could pass the array into a pointer p. Okay, so now the p is just pointing to a m n. Okay, so we could increment p by 1 and read off all the elements of that array one by one, okay, in a serial fashion. And another way to do is to point a one-dimensional array, or we could pass the elements of the array into a one-dimensional array of pointers. Okay, so here it was passed to another array, and here passed to a pointer, and here is passed to a pointer array, a one-dimensional pointer array. Okay. Or you could do that by just passing to a two-dimensional pointer array. Okay, so there are 4 different ways of passing an array to a function. So I repeat that: this array to array, array to pointer, and array to a one-dimensional array, and array to a two-dimensional array. Okay, so that's what we should see in a sample code. Okay, so here is a sample code for that. We have declared an array. So this array again has 2 columns and 5 rows. And then we have declared here 3 integers and 1 pointer, right? And the array dimensions are 5 and 2, 2 columns and 5 rows. And now we would call 4 different functions. Okay, so we call 4 different functions and pass the same thing. Array, the call is the same. Okay, we are passing array, the dimensions of the array, the number of rows, and the number of columns to all these functions. We call it print, show, display, and exhibit. Okay, so 4 different functions. Okay. So now what are these functions are? Since the functions are given here, so the print gets it as an array, a 2-dimensional array. So it gets it as an array. Okay. And display gets it as a 1-dimensional pointer array. Okay. Show gets it as a pointer. Okay, and exhibit gets it as a 2-dimensional pointer array. So that's the 4 different ways of doing it. So first it's just array to array. That is, remember the previous call, that the call is the same. Everything is just passing the array. Okay, but in the functions, the print is as a 2-dimensional array, and in the show, the program called the function called show gets it as a 1-dimensional. Gets it as a pointer, and the display gets it as a 1-dimensional pointer array, and exhibit gets it as a 2-dimensional pointer array. So now you see that, so that we have declared that here. Okay, So we got it as integer here declared, integer pointer here, and this is the pointer array here, and integer 2-dimensional pointer array here. Okay. So now how do we print them out? So we can here, when you pass it to a function as a array itself, we can print it out as a pointer, the elements of the array simply by saying, by just reading out the array elements. Okay, so when we have pass it as an array, okay, so now here it gets it as it's a pointer, right? So here the array is passed to a pointer. Now we have to increment the pointer and run through the whole array. Okay, that's what we are doing here. So watch. So we need this number 2 here. Okay, that is the number of columns which we have. Okay, so I basically is a number of running through all the rows. Okay, I could have put in here p straight away instead of I star 2. You could have put I star p because p is the 2, right, which is the number of columns which we passed. Okay, so now we are running through this all the rows and printing out both the columns. Okay, so the first row, so I is 0, that is first row. Okay, we print the first element and the second element, right, and then we increase I, and then we go into the first element of the second row and the next element. Okay, so that way we can print out all of them. Okay, so that's what we are printing out. So let's see that one by one. Okay. So the print just prints out all the elements as 1 1 1 2 2 1 2 2 3 1 3 2 4 1 4 2 5 1 5 2. So it's just printing out all the elements by this. Okay. Now here we are again using this asterisk sign to read out the number of that array, right? Okay, so because b is a pointer. Okay, so now then we increment b by this elements and by the number of rows and the column, okay, and then we print that out and we get exactly the same number, of course. And then there's the third way is to use the display function, which is actually getting the array as a one-dimensional pointer. Okay, so now one-dimensional pointer array. So now one-dimensional pointer array we need another pointer to point to that and then read out the elements, and that's what we do here. We have declared another pointer p, right, and then p is now pointing into the array b, the pointer array b. So now p is a pointer and there is a pointer array, so we have to typecast it. Okay, so that p equal to integers star b. Okay, and then we increment p, right? So we take p and p plus 1. Okay, that gives you the array, and then we increment b, and then that goes to the next row, right? So then we again point that p to that the incremented b, and then again print out that thing. That's what we're doing in the display function. So the display function we will get 11, 12, 21, 22, 31, 32, 41, 42, and 51, 52. Okay, so we have got array to be printed by passing it onto a function which is a one-dimensional pointer array. And the next one is to pass it onto a two-dimensional pointer array. Okay, so that is declared here. Again, now b here is a two-dimensional pointer array with the dimensions 5 and 2. Okay, so now we can read out this simply by this statement. So that is now very similar to using this array itself. Okay, so it's very similar to that. Only thing we have to use this asterisk signs to print out the the actual variable value. Right. So that's what we are doing here. So we print it out by going through all the rows and the two elements of the row or the two columns. Okay, we just print that out. Okay, and that we can see here again. Again, we get the same numbers. Okay, so what we have done, we have seen four different ways of passing an array to a function. Okay, so that is array to array, array to pointer, array to one-dimensional pointer, and array to a two-dimensional pointer. Okay, so that's what we have done. Okay, so now we will see how the function can return an array back to the main program. That's what you should see next. Okay, so now returning array from a function, that's what we are going to see the next one. Okay, so now again, so we saw four different ways of passing an array to a function. Okay, now what we see is that the way we can return it is three different ways. Okay, so that is again array to a pointer. So now the program is returning, okay, the function is returning an array, okay, after doing whatever it has to do with that, okay, back to the main program or the program from which it is called, right. So main function from which it is called. So one way to do that is to return an array to a pointer, okay, or we could return an array to a pointer array, okay, or we could return an array to a two-dimensional pointer array. Okay, that's again three different ways. We can't return an array to an array, as you might have noticed. Okay, so we have three different ways of doing that: an array to a pointer, an array to a pointer array, and an array to a two-dimensional pointer array. Okay, again the best way to see this is to look at an example. So here is an example of a program. Okay, so now here this is a main program, and then you have the functions. Okay, so we are calling the functions matrix 1, matrix 2, and matrix 3. Okay, so we will see this later. This function calls a little more detail. So here we are declaring the functions. The function has to return something, right? So the function is going to return an array. That's what this program is going to demonstrate. Okay, so because of that, so we have to say what type of variable the function is going to return. So here it's integer. Okay, so the function is declared here. It's an integer. Okay, so all integer matrix 1, matrix 2, matrix 3 are integer pointers. Now here is our pointer array declared, and here is another pointer declared. A and R are two pointers declared. I is an integer. Okay, so let us see. So we have a matrix A, right? So we have the pointer A. Okay, now that's been pointing to the matrix 1, this function. Okay, so now what's matrix 1 doing? We will see that, okay, later. So this matrix 1, and we are going to print. Now we are going to print that values. Okay, so that's what we are going to see. We will see this program, and then we will go through the details once again. Okay, so returning array from a function, that's what you're going to see. So that's the same program which is listed there. Okay, so we have matrix 1 and matrix 2 and matrix 3 as that. Okay, and then we're going to run this program, and we'll first, before we run the program, we'll just look at this function matrix 1. Okay, so here is the function matrix 1. Okay, we'll look at them one by one. So we look at the function matrix 1. Okay, so that has an array declared there. Okay, so you have an array declared. Okay, so that is so array ARR. Okay, and that has got 1, 2, 3, 4, 5 rows and 2 columns. Okay, and it returns this array. Okay. So what does this function do? This function simply returns this array. Okay, it is an array is declared here, and it just returns. Okay, this right. So the array is declared returned back. Okay, as a pointer. Okay. And remember our the program above. Okay, I said A, which is a pointer. We said that that's equal to that's my statement. A equal to matrix 1. So the matrix 1 would simply return that array into this pointer A. Right. That's what happens. Okay, and then what happens if you run this? And we'll see that. Okay, so we have matrix 1. Okay, so I'm just printing out just for clarity that this is from matrix 1. Okay, and then we are printing out the array elements. So we printed only 4 array elements here. Okay, yeah, okay, because I said I less than L, so it goes up to 0 to 3. Okay, there's 4 rows I'm printing out. Okay, so it's 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2, 4, 1, 4, 2. Okay, so you can notice that here I'm just running through. This is just a pointer. A is a pointer, so I'm running through as we did in the case when we pass the function to the array, an array to the function. We are doing exactly the same thing here, but now we are printing out in the main function. Okay, not in the main program, not in the function. Okay, so we are printing out that. So this A was equated to matrix 1, and we saw matrix 1 simply returns an array to this. to this pointer. Okay, so that's what we did. So again, let's look at that one again. Matrix 1, it just declared an array, and that array was returned as a pointer to the main program. So remember, I have to declare the array as A as a pointer here, and also the matrix 1 as a pointer here with a type integer. Okay, this is important because it is a return to that. Okay, so next one is matrix 2. Okay, now matrix 2 is declared again as type integer. It's a function, and it's a pointer array. Okay, this function is declared as a pointer array. Just please notice the way it is declared. It's a pointer, okay, and it is an array. Okay, and it is an array of 2 columns. Okay, so that's the way it's declared. And then what does it do here? The matrix 2 part. Okay, it is again. Okay, it is declared an array. It's very similar to this. It is declared an array, and it is returned now as. Notice the difference. Okay, it is returned as asterisk ARR here, and it is returning as ARR here. Okay, so that's what we see here also. So we have matrix 2. Okay, and the matrix 2 is just simply returned as ARR. Okay, and I'm going to when you run that, you see it gives you exactly the same value. Just another way of doing the same thing, but it gives you exactly the same value as matrix 2 gives you exactly the same values as the previous one. Okay. So now we have the third call, that is, now we saw returning into a pointer, and we saw returning to a pointer array, right, one dimensional pointer array. Okay. And there are different ways of returning it. So you have to remember that is even though the call is the same, the way it is returned is different. So it is here there is an asterisk sign ARR, and here is just simply ARR. Now we see how can we return a matrix into a 2-dimensional pointer array. Okay, so now again the return statement is very different. Now we have to put a type statement here and then return that. Okay, so we said integer star the dimension of the array and the array. Okay, so the same array is declared here, and we return this in this fashion. Okay, and we get as you can see, we get exactly the same value here. Okay, so let's go back and then once again look at the calls. Okay, and so we had the first function matrix 1 declared as an integer pointer, the second function matrix 2 declared as an integer pointer array, and the third function matrix 3 which is declared as an integer 2-dimensional pointer array. Okay, notice that this is a 2-dimensional pointer array. Okay, and so depending upon what the function is returning, okay, we have to declare it properly, right? So, and to what value it is declared, what is the variable or pointer to which it is declaring, that also has to be declared properly. Okay, so here we return it to we say A equal to matrix 1, so that has to be the same type, right? So we have integer, okay, and pointer, this is a pointer. Okay, and this matrix 2 declared returned that into a 1-dimensional pointer array. So we have declared both B as a 1-dimensional pointer array and matrix 2 as a 1-dimensional pointer array. So that's one thing. Okay, and now matrix 3 is returning the function into a 2-dimensional pointer array, the C. So we have here again we have to declare C as a 2-dimensional pointer array and the matrix 3 as a 2-dimensional pointer array. Okay, so that's the summary. So summary is that we have 3 different ways of returning an array, a 2-dimensional array to a function, and we have 4 different ways of passing a 2-dimensional array to a function. So that is what we saw. So now before we go into other details about function, okay, one more point which about the pointers which we should know is that's a dynamic memory allocation. This is an important fact that when we declare array, we saw arrays so far. Okay, so when we have arrays, we have when we declare an array, we allocate some memory to it. Okay, and that memory allocation is static. The moment we declare an array, okay, that memory has been allocated to it. Okay, but sometimes we want to declare something, but we don't want to allocate the memory till we do something else. We actually use that that variable. Okay. So in that case, which is useful to have a way of doing this. Okay, so that is one way of doing that is uses dynamic memory allocation. Okay, so that is the use of this. Again, I may emphasize there are two. The reason for or the use of this function is that when we define arrays, it uses a static memory. That is, memory allocation is static. It takes place in the beginning of the program. Okay, but we may not need this all the time, or we may want to have memory allocated to the allocated only when we use that variable, and then we can use this functions called malloc and calloc. Okay, so there are two built-in functions called malloc and calloc, and we can use that to allocate memory just during execution. Okay, so that's what we're going to see now. Okay, so and then we can use a size of function. Okay, there's another function. So the three important functions with dynamic memory allocation. One is malloc, calloc, which is actually similar, in fact almost the same in most of the compilers. Okay, and then another thing called size of. Okay, so this is to allocate memory, and size of can be used. It's a function which we use to determine the number of bytes occupied by an entity which we have allocated memory to. Okay, that's what we would see now. Okay, so here is a program which uses all of that. Okay, and so let's go through this program. Okay, and then we will run it and then see. We will step by step. Okay, so we have declared an integer pointer a and a pointer p and an integer I. Okay. And then we use a float pointer b and c. Okay, so now we want to put in a value, okay, some number into this a. Okay. So you can't simply say a equal to star a equal to something to begin with, because a is just declared as a pointer, but we have not actually allocated any memory to that a. Okay, it's just an address right now. So we want to it's just a declaration right now. We want to allocate some memory to it, and then only we can put in some value into it, right? Okay, so that's what we are trying to do here. So we say that okay, we have to define some variable L as 4. So that is, and then by this is a use of the malloc function. Okay, so a is equal to integer star malloc of L. Okay, we will see this again in the and we will run this and see. Okay, so here. So I have declared this as the same program. Okay, so now we have a as a is a pointer. Okay, now that pointer has been allocated some memory. Okay, so if you have declared a as an array, okay, for example, this is substitute for the array as we said. So, instead of a static memory, a dynamic memory. Okay. So let's say a we want to put in four values. Okay, so you could say that okay, L is 4 here. So I could now declare the amount of memory which is to be allocated to that. Okay, so I know, let's say in this stage of the program, I know what should be my array size is. Okay, then I can use that array size and allocate memory to this. Okay, dynamically during execution. Okay, so this is the way to do it. So I said a is an integer. A is this array is now an integer. Okay, integer type, and it is in dimension L. Okay, so then I'm going to allocate memory for that. Okay. Then I can put in values to it. So I just now this is an assignment statement. So I'm putting in asterisk a plus I as I. Okay, and it's some number. Okay, I just put it as I here. It could be any number. I'm just assigning I'm just assigning values to that array elements, and then I just print that out. Okay, just show you that print that out. I can print out the address and print out the values. Again, two different ways of getting that array elements. Okay, so I print out the value of I, which I put in inside that. Okay, and I put in the value of that element a of a plus I and the address of that element a plus I. Okay. So that's one way of assigning. Another way of assigning is now I have declared similar, exactly similar, another pointer p, okay, and I am showing you how you can allocate memory using calloc. Okay. So now in calloc, in some compilers, okay, the slight difference between calloc and malloc is that when you use calloc, you have to tell what type of variable that is inside this function. Okay. So, but this is depends on the compilers. Modern compilers, this is not required. Okay. And another difference between malloc and calloc is that in malloc, when you allocate memory and you don't put in any variable, it puts in some garbage into it, while calloc initializes that to 0 if you don't put in anything. Okay, and this is again compiler specific. Okay, in most of the modern compilers, there is hardly any difference between malloc and calloc. We could use both interchangeably. Okay, so here again is exactly the same thing. I have put p. I have allocated memory to p, and I put in p as now instead of I put I star 2. Okay, and I can print out that. And I can also use now this print statement. I am also using this function to demonstrate the size of p. Okay, that's the number of elements, the size of the entity p. Okay, which is so we will run this and then we can see this. Okay, so now so that's how I allocate it into a and p, the two integers. Okay, and then I show you that I can allocate also. So that's for the integer type. Okay, now here is I'm allocating for a floating point type. Okay, so it's so as you can see that actually you should declare here what is the type is. Okay, but it's not required in this case. Okay, so b equal to I say malloc of I. Okay, I can do that. Okay, and calloc would be, you would again say what the type is by putting the number here. Okay, so integer, if it's an integer, I would have put 2, and if it is a floating point number, I put 8. Okay, so that's two different ways of doing this, malloc and calloc. Okay, so now this is a floating point. B and C are float variables, and while my P and A were integers. Okay, so this is what we're going to demonstrate here. Okay, and I'm just printing out these variables. Okay, so we'll see that in this program. Okay, so now that's been printed out. Okay, so now we have to go through this one by one. So we have used first A. Okay, so then we have, as I said, we put in four values into it. Okay, so now that's address. Okay, the values were just simply I. So A of 0 is 0, A of 1 was, remember A was put in as just I itself. Okay, so A of 0 is 0, A of 1 is 1, A of 2 is 2, A of 3 is 3. And the addresses, you can see the addresses are printed out here. It goes just by 4, okay, 36, 40, 44, and 48. Okay. And then we had the calloc function we use here. Again, it's similar. So we again put in 4 values. We use the calloc as an integer type. Okay, and then we again print it out, and we set the size of that. Okay, the size of the array. We actually had 4, so the size of the array is 4. Okay, so so we use the size of function. Remember, so here we can see that when we are printing it out. in the case of p, we use the size of p as another print variable, right? Okay, so that is that has been given as 4 because we allocated 4. Okay, L is 4 declared here, and we use calloc, we use L as 4, so it's got 4 size. And then we now this is the next part was assigning floating. Okay, so here we had used b is equal to malloc L, and b is now float, right? It's a float, so it's a floating point variable. Okay, so then we again have the values. The values we put in here was I star 4. Right. So when I is 0, it's 0 and it jumps by 4. Okay, so we have 0, 4, 8, 12, 16 and 20. Okay. So now you notice that again the addresses jumps by 4 and the size of function is again giving us 4, the dimension of that array. Okay. And similarly another thing which I declared, now using b, using calloc, okay, the similar one. Okay, and here you can see that again. But now again I declared this thing, and you get again the addresses, the variables and the size of function. Okay. So to use size of function, it doesn't matter whether you use malloc or calloc, it's just the size of the array. So we can use the size of function to pick up the size of an array which has been used. Okay, so that's what this program demonstrates to us. Okay, we should just look at a summary of the functions. We said we can pass array to a function, we can get an array from the function, and we know how to declare arrays, we know how to declare pointer arrays, we know how to declare pointer arrays such that we can allocate memory dynamically, and how to get the array size and things like that. Okay. So before we go into the next part of the pointers, that is pointer to a function, okay, let's just go through the thing, just review the idea of function itself. Okay. So remember, all functions have the following form. Okay. So next part we are going to do is actually looking at how to make a pointer. Now so far we looked at pointer at a one-dimensional array, pointer at a two-dimensional array, and things like that. Okay. And now how to allocate memory. Now we want to know how to define a pointer to a function itself, and how do we pass that pointer to a function to another function. Okay. This will be required. We will see that where it will be required and how we are going to use it. So here, so before we do that, let's just summarize what we know about functions. Okay, so we have all functions have the following form, right? So the function, if it's returning something, we have to say what type it is. If it's not returning anything, we would say void, right? Okay, and then we have function name, and then the arguments passed to the function. So this is the generic name of the thing, right? And in the function, okay, itself. Okay, so that's the way we call it, and we declare it, and in the function itself, the similar declaration. We have the type and the function name and the arguments passed to the function. And now the arguments, the type of the arguments can be given inside this brackets, or we could be given outside, just below that. Okay, the variable declaration of the arguments can be included inside this bracket, or we could have it outside. We saw that also. Okay, so now then we have inside the function the local variable declarations and statements. Okay, so statements. So that's what we saw. For example, print functions, we saw the statement was just simply print, or something has to be returned, then we say return. So this variables. Okay, so now so then argument passing. What is the different ways of argument passing? We saw call by value and set. Right here, the function work with a copy of the variable. Okay, and so changes made in the function will not affect the variable value in the function from which it is called, right? That's we saw. It's called call by value. Okay, as opposed to call by reference, in which we pass the address to the variable. Okay, and in this case, whatever changes which is made inside the function would affect would change the value even in the function from which it is called, function or main program from which it is called. Okay. So we saw that. So we'll just looked at an example once again of this function calls. So here again, this is argument passing. We just saw that. So and here I am using also the malloc. Okay, so this is a summary again. Okay, so we have here. We declared a function. Okay, so this function is not going to return anything. Okay, so we declared a function called my function. Okay, so it's not going to return anything, so it's called void, right? And then we have variable, a floating point variable. We have an integer array, and we have a pointer C. Okay, so we have everything which we have learned about pointers here, okay, except two-dimensional. Okay, so now then we assign some we are assigning some memory to that pointer C. Okay, so we put some memory. Okay, and then we have this floating point. We another assignment statement, right? So the floating point B has been given value 10, and this variable C has been given a value 5. It's an integer, right? So it's declared as an integer. Okay, here we declared this as an integer. Okay, and then we have the arrays, and we have given some values to the arrays too. Okay, and then what we do here in the program is we print out all these functions before these values before we call a function. We're just printing out all the values. Okay, what are we printing out? We're printing out the value of B, so %f because it's a floating point. We're printing out the value of A of 1. Okay, so that is %t, and then we are printing out A of 2, and that is again with 2 are integers, so %t. Okay, and then we are printing out the value which is in the variable C. Okay, we are putting some value C, and that's again an integer. And then we call the function. Okay, and we print out exactly the same again. Okay, so now we're calling the function. So we're calling the function with value B. So B is just a floating point. So we're going to call this by value. And we are passing an array A, and we know that array is also a pointer to its base address, right? The array name. So actually this is a call by reference, right? We have seen all arrays are called by reference, and C is of course a pointer, so C is called by reference. Okay? So now we'll do the function. Okay, we call when we call that function, and we print out the values of A, B, A, and C after the function call. You know what do we do in the function? So inside the function, now it's received as, so remember we call this function as B, A, and C. Okay, and it received as X, Y, and D. Okay, now this is a function declaration. Okay, so this is void, it is not returning anything. So it's function name, variables. Now variable, the declarations are, it's a floating point, X is a floating point, Y is an array, and D is a pointer. I could do exactly the same thing inside this bracket, okay, and avoid this line. There are two different ways of doing it. Okay. So then we have a local variable. Local variable is Z, is a floating point, and now we are going to change X. Okay, so X is passed by value, we said, right? So X is B is a floating point, and X is a floating point. So this value of B has been assigned to X, and we changed X here. Okay. And then we change Y. Okay, we changed Y. So this is an array. Okay, this is an array. Okay, we change the value of Y. Okay, we change Y to 3 times Y. And then we have a D, which is a pointer, right? And then we change the value of D by adding 2 to D. Okay, so that's what we do in the function. Okay, and then we're going to print out. So we just call this function is not doing anything else. It's not returning anything. It's not printing out anything. It just changes these values. It change the X, Y, and D values. So we're going to print out this before call and after call, and then we'll see what happens. Okay, so before call we had 10, 1, 2, and 5. Let's look at that again. Okay, so we had given A1 as 1 and A2 as 2, okay, and C as 5 and B as 10, right? So that's what we had. Okay, so we had 10, 1, and 5. And then what we do in the function? In the function, we changed X, which was B, right? B was passed as X, that is changed. Okay, we changed Y and we changed D. Okay, that means we basically changed, whatever passed onto it is changed. Okay, and then we go, and then what do we see in the when we print out B, A, and C after the function call? The B is not changed because it was passed by value. Okay. And we see that here A was passed as Y, and we changed Y. But when we changed Y, the A also changed, right? So we're going to change to 3 and 6. We multiplied Y by 3, then A also changed because it was passed by reference. Okay, because an array is a pointer to its own, to its base address. Okay, so all arrays are passed by reference. Okay, so it's when we pass by reference, you change the value in the function, it will change the value in the main program. Okay, now. Then we see D also. D is again an array. A pointer. Okay, so it's again passed by reference, Okay, so you change the anything which is passed by reference inside a program, it changes in the main program. Okay, so we see that when we added 2 to D, which is actually C passed as D, we added 2 to it, it changed the value of C, and that's what we can see here. Right. So this is not surprising, because it's just, C and A here are just pointers to some addresses, and what we are doing is we are actually changing that value which is put in the address, so it just reads out what is the value there, and that's been changed. Okay, while when you pass by value, that's like B, which is when passed by value to X, okay, X is a different memory location from B, okay, and what you change in X is not going to change what's in the B. Okay, so that's the point here. Okay, so now we see maybe the last part of the pointers is to see pointers to functions. So now this is also required many times, because we may want to pass a pointer, pass a function, okay, to another function. Okay, so that this is useful. And we can assign a pointer. So we saw that pointers can be assigned to some variables, right? So we equate the address. We can use a pointer to point to some address of some variable, and we can also use similar way a pointer to point to a function, okay, like an array, like in an array. Okay, so then we can use that pointer to invoke that function. Okay, so the pointer to a function should be okay. Now then the pointer to a function should be the same type as the function itself. Okay, so this is important, similar as what we used before, right? So when you're pointing a pointer to a particular memory location of some variable, there should be same type, right? Okay, and then we can use the pointer to invoke a function. And then what is the use of this? One is that passing, so we can pass the function pointer to another function. Okay, and this is especially useful when we are using some standard libraries and things like that. Okay, where the user some user defined function may have to be passed. Okay. So in that case, we can use this this property or this function. We will see that. Okay, so, that how do we do this defining a pointer to a function, and how do we pass that function to another function. Okay, so only point to remember is that the function and the pointer should be of the same type. Okay, the function you're calling is of integer type. The pointer also has to be integer type. Okay, and one more important point is that the function which you're going to call by referring to by assigning it to a pointer should be declared outside the main program. Okay, it should be global to the whole program. Here we'll see that all in an example. Okay, that's the best way to see it again. Okay, so here, so for example, let's look at the main program. Let's forget about this and just look at the main program. Okay, so here it is that I have some floating point declarations. It's in an array, and there is a pointer, and there is a value b, etc. So here, this is what I wanted to show you. So here is a function pointer. Okay, I call it a function pointer. Any name can be used. Okay, but it's a function pointer. So because there's a bracket outside. Okay, so and this is the type is void. It's not returning anything. Okay, so if I want, remember my function program before. So the same my function. If I want this function pointer to point to my function, okay, and then they have to be the same type. Okay, that's the important point. Okay, and so this is program which we just saw. I'm just using the same program which we just saw. Okay, and we are going to invoke that using the function pointer. Okay, so instead of there I had called in the previous program, I just called, if you remember, that I just called them by saying my function a, b, a, c, right? So I won't do that here. Okay, I have declared a function pointer, and I'm going to point my function pointer to that my function, and I'm going to invoke that function by using this my function, using the pointer name. That's another way of doing it. Okay, so okay, so that's what we would see here. Okay, so now I added one more thing into this function. Here is that now I can also pass. So see, now there is another function which I have declared outside. Okay, which is called cube. Okay, so this function has been declared outside. Okay, there are various ways of defining it. Okay, So this function we'll go into that. Okay, this function has been declared outside the main program. That's cube. Okay, and I can pass the address to that address of that function. Okay, address to that function. Okay, into another function. Okay, that's my function. Okay, to my function I am passing the address to that function. Okay, and that's what we are going to do here. Okay, and then we will run this, and my function gets it. You see that my function is a program that gets it as whatever I called as cube here, okay, which is defined outside the main program. It gets it as power 3. So let's say this is part of a standard library, okay, and it wants a particular name of the program there. It doesn't matter. You pass that address to that function. Okay, it goes into whatever name which is declared here. Okay, this power 3, and inside this function I am calling power 3. Okay, again by pointer. Okay, so this cube has been passed as power 3, and power 3 is invoked there, and then that is executed and printed. Okay, so that's what we are going to do. Okay, so and the function cube. So this is user defined function. Let's say this was a part of a standard package. Okay, and it wanted a user defined function to compute the cube, right? Okay, and then what we do is we declare the function cube outside. We write the program, the user defined program cube. Okay, and we write that thing. Okay, and then we put that back into we put it in the main program. We call it. We put it outside, declare it outside the main program, and we call it as cube. Okay, and the standard package which gets it as power 3, and it computes that, and that's what we would see here. Okay, so we'll just look at that as. Okay, so here is the same program. So I have declared the main function. So this is the main function. It's void. It's not going to return anything. Okay, and then we have the pointer to the function and my function itself. And then when I call that function using this pointer, I pass the address to that user defined function cube. Okay, which is defined outside, which is written here. Okay, so now we will run this. We did two things here. That is, we have declared a function pointer, and we also wanted to pass pointer to a function. So two things we want to do here. Okay, so that's what we did in this call in the function point. We use a function pointer here, which is pointing to my function, and we use that function pointer to invoke my function. At the same time, inside this my function, I pass an address to another function called cube. Okay, so that's what we've been doing. So we'll just run this now, and we'll see. Okay, that's what we did. So we now have one more thing here. So, okay, that's like the earlier one. So we had passed a variable by value, and then a variable by reference, and then we also passed the function. So we passed a name to a function. Okay, so that function is called cube, right? Okay, so now the cube is printing out. So as we said, the cube is printing out the cube of that. Okay, so what is the function cube is doing? It is not returning anything inside that function. It's just getting the value x. Okay, and that value x, the cube of that, has been printed out, and that's what we see here. Okay, so we can that's been the cube of that function. Okay, so that's basically this program do two things to repeat it again. That is, we use this function. This is a way to invoke a function by using a pointer. So we can point something into a function, and then use that pointer to invoke that function, and then we can declare some programs outside the main loop, and then we can use the address to that main loop to that programs, and pass that to another function. Okay, so we pass that to another function, and then which would call it by reference to using that pointer. Okay. So that's the summary of the pointer thing. So now I think next lecture onwards we would probably put these things into use to do some actual numerical calculations. Thank you.